Hi everyone, welcome back to my channel. Today's topic is another very simple and one of the important part of carbohydrate topic. We are learning about glycogenesis today. Let us start with a little overview in glycogenesis. Glycogenesis simply is a synthesis of glucose, meaning converting glucose into glycogen to use later when your body is low in blood sugar level or when your body is in fasting state. Glycogenesis process occurs when your body has high level of blood glucose or insulin, and it primarily occurs in liver and skeletal muscle. It starts with a simple step where glucose phosphorylates to glucose 6-phosphate, and during this step, 1 ATP is consumed, which traps the glucose inside the cell. And also ADP is formed during this step and released quickly as well. This process is catalyzed, meaning accelerating the reaction by glucokinase enzyme in liver and hexokinase enzyme in muscle. So that is basically a first step, and keeping that in mind, we move to next step where G6P is isomerized into glucose 1-phosphate. Phosphoglucomutase enzyme catalyzes this step. Again, G1P is then converted into UDP glucose, which sounds simple, but there are many steps involved here. During this step, G1P reacts with uridine triphosphate UTP, which releases pyrophosphate, which is later hydrolyzed into 2-phosphate molecule. Now the result, UDP glucose, has a glucose, 2-phosphate group, and an amino acid uracil. Again, keeping these in mind, let us move to a very important step. UDP glucose helps form alpha-1,4 glycosidic bonds. Let's see how this step takes place. Well, during this step, two main enzymes, glycogenin and glycogen synthase, are used. Glycogenin adds UDP glucose, one after another, to the hydroxyl group of its own tyrosine residue and making the chain of 7 to 8 UDP glucose. Tyrosine here is a residue that serves as an anchor in initiating the primer chain for making glycogen. It acts as an acceptor of first glucose molecule. While forming this base chain, glycogenin takes the glucose from UDP glucose and releases the UDP on the process. Now the bond linking these glucose molecule is called alpha-1,4 glycosidic bond. If I haven't said it earlier, glycogen synthase, the other enzyme, needs a primer in order to add more glucose to elongate the glycogen chain. Now we have that primer for more glucose molecule to be added. So glycogen synthase adds the glucose molecule to the non-reducing end of the glycogen chain, which is the opposite side from where tyrosine residue is. Then it adds more glucose molecule by transferring glucose molecule from UDP glucose and releasing the UDP in the process. UDP is later converted into UTP. Once again, the link between these molecules are alpha-1,4 glycosidic bond. Hence, alpha-1,4 glycosidic bond as a result. Now is a final step where alpha-1,4 glycosidic bond is converted into alpha-1,6 glycosidic bond by branching enzyme. It's already in the name, branching enzyme branches out the chain, forming a bond. So when the chain reaches to certain numbers of residue around 11 to 15, branching enzyme comes in action. It removes around 6 to 8 chain of glucose molecule from non-reducing end and attaches it to an internal positioned residue. And the link formed between these attached molecule is called alpha-1,6 glycosidic bond. As a result, two non-reducing ends are formed and elongation can continue to form from both sides. More and more branches are created by the same process over and over. This process repeats several times to form a glycogen molecule. A little look to glycogen, which looks like an abundant tree like branches originating from core glycogenin. Well, that is with the final part of glycogenesis. I have divided the whole process into 3 parts. Hoping it helps you guys. It sure did help me. And thank you so much for staying till the end. Means a lot. Please do like and share my video and subscribe my channel Flipping Nutrition if you like the content. See you soon.